One of the places we often run into trouble using the quadratic formula is in situations where one of b or c is 0. So either there's no x term or there's no constant term. In these cases, another method of solving our quadratic equation will be an easier method, but we can still use the quadratic formula. So here we have the quadratic equation 3x squared minus 25. To make that look like a quadratic equation in standard form, when I copy it, I'm going to write in a plus 0x term. Adding 0x doesn't change anything. It just makes it so I can see the x term. I can see that we have a equals 3, b equals 0, c equals negative 25. And so when I plug into the quadratic formula, remember the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. When I plug into the quadratic formula for this equation, I'll have x equals the opposite of 0 plus or minus the square root of 0 squared minus 4 times 3 times negative 25 all over 2 times 3. So that'll give us x equals plus or minus the square root of 300 all over 6. Now, the square root of 300, that's going to be the square root of 100 times the square root of 3. So that's 10 times the square root of 3. So my x is plus or minus 10 times the square root of 3 over 6. 10 and 6 have a common factor of 2. So I'm left with my two solutions being x equals 5 root 3 over 3 or negative 5 root 3 over 3. So, okay, so those are perfectly good solutions, but I think that there's an easier way to solve this. We could solve this using the square root property directly. So we have 3x squared minus 25 equals 0. We could just get x squared by itself. So first add 25 to both sides. 3x squared is 25. And then divide both sides by 3. X squared is 25 over 3. And finally apply the square root property. X is plus or minus the square root of 25 thirds. Let's simplify that square root. So the square root of 25 over 3 is the square root of 25 over the square root of 3 is 5 over the square root of 3, which looks different from that first answer. But let's rationalize the denominator. To do that, we'll need to multiply by root 3 in the numerator and denominator, and we'll get 5 root 3 over root 9, which is 5 root 3 over 3. So x is plus or minus 5 root 3 over 3. We can do that with the square root property directly because there's only one term with an x in it. If we don't have both an x squared and an x term, we don't need to go to the quadratic formula. We can just apply the square root property directly. In this next example, we have no constant term. So we have 4x squared minus 11x equals 0. To use the quadratic formula for that, I'm going to write plus 0 as I'm copying this, so that it's easier to see that this is a quadratic equation with a equals 4, b equals negative 11, and c equals 0. So plugging in, we get x equals the opposite of negative 11 plus or minus the square root of negative 11 squared minus 4 times 0 all over 2 times 4. So x equals 11 plus or minus the square root of 121 over 8 is 11 plus or minus 11 over 8. We could have x is 22 over 8, which, canceling a common factor of 2, is 11 over 4. Or we could have x equals 0 over 8, which is just 0. So those are relatively nice solutions, right? We didn't end up with an irrational square root. And in fact, we could have solved this by very easy factoring. Right? We have 4x squared minus 11x equals 0. We see that the left-hand side has a common factor of x. So this is just x times 4x minus 11. We can either have x equals 0 or 4x minus 11 equals 0. Solving the second one, 4x equals 11, x equals 11/4. So it's not just the case that we could solve this quadratic equation by factoring. We could solve it by really, really easy factoring, right? Just factoring out the common x. So when we have a quadratic equation that has no constant term, we can solve it by really, really easy factoring. When we have a quadratic equation that has no x term, we can solve it really easily using the square root property. We can use the quadratic formula in these two cases, but we probably shouldn't. We should probably use those easier methods instead.